intro.
Hello students! We are currently in the month of September, also known as Science Month celebration, who envisions 21st century learners who will create scientists for the future generation. And as the students of San Diego Parochial School, we will perform an experiment entitled The Elephant's Toothpaste. But what is elephant's toothpaste? Elephant's toothpaste is a foamy substance caused by the rapid decomposition of hydrogen peroxide using potassium iodide or yeast and warm water as a catalyst. This demonstration is called elephant's toothpaste because it looked like a toothpaste coming out of a tube. It is so big that only an elephant could use. Before starting the experiment, we must first use protective equipment. We must put on goggles and gloves for protection. And the concentrated hydrogen peroxide used in this experiment can burn skin, eyes, if not protected. It can also bleach fabric, so choose clothing wisely. Now, we can start our experiment. First, we need two chemicals. The first one is hydrogen peroxide. We all know that H2O is water, and by adding one more oxygen atom, it will make this chemical called hydrogen peroxide. The other chemical we will use is the potassium iodide. To start the experimentation, first, we are going to pour the 10% hydrogen peroxide in the flask. We are going to conduct the experiment. Second, we will add the dishwashing soap and a few drops of food coloring into the flask. Food color helps to make the foam more attractive when it comes out of the flask. Next, let's add the catalyst, and that is potassium iodide, to the water. The purpose of it is to speed up the escaping of reaction. And this is an example of the chemical reaction that has been accelerated.
That we humorously call making elephant toothpaste.
Boy, the Germans sure know their humor. Let's just hope they know something about chemistry.
First, add a tablespoon of dish soap to hydrogen peroxide, then add the warm water and the yeast. German chemistry!
When we add potassium iodide to the hydrogen peroxide, the reaction is taking place as soon as we pour it. When the hydrogen peroxide comes into contact with the catalyst, it starts breaking down into the water and oxygen. The reaction continues as long there is some hydrogen peroxide and potassium iodide left. Once one of them runs out, it stops making new foam. But what if we use 30% hydrogen peroxide? In this experiment, our purpose was to test how percentage of hydrogen peroxide and its amount can affect the speed of the chemical reaction. Our hypothesis stated that the trial using the 30% solution would be the fastest, and it was proven correct. It was the fastest because it had more hydrogen peroxide, making it have more oxygen when broken down and pushing the foam out faster.